All right, so we hear all these explanations for how AI works, but let's be honest, most of them just scratch the surface. Today, we're going to go deeper. We're pulling back the curtain on those simple analogies to look at the fundamental and, frankly, beautiful principles that make all of this possible. Let's dive in.
You often hear something like this, right? AI takes reality, language, images, whatever, chops it into tiny pieces, and learns how they all fit together. And you know what? It's a great starting point. It gets the basic idea across, but it kind of misses the most magical part of the whole story.
Because that's exactly where we're going. We're about to explore how the real genius of these systems isn't in the pieces themselves, but in the incredibly complex, geometric web of relationships that connects them. The magic isn't in the bricks, it's in the architecture. Okay, first things first. Why do we even have to chop things up? Well, it's a fundamental problem. We live in this smooth, continuous, analog world, but computers, they're digital. They think in neat, separate, discrete units. So to get reality into a machine, you have no choice. You've got to slice it up. And this slicing happens everywhere. We break language into words or parts of words called tokens. Images get turned into pixels. Audio becomes tiny frames of sound. But here's the crucial thing to remember. These tokens are not reality. They're just measurement points, kind of like the tick marks on a ruler. They help us measure the world, but they aren't the world itself.
Now this is where it gets really cool. A token doesn't just stay a simple piece or a number. The system does something incredible. It transforms each token into a coordinate. I want you to picture it like placing a single pin on a massive, unbelievably complex, multidimensional map.
The technical name for this coordinate is a vector, but don't let that word intimidate you. All it is a point on a map. And what's so important is not the point itself, but where it's located in relation to all the other points. Its position, that's what holds all the meaning.
Just look at this example with the word river. On this giant map, its vector is placed close to related concepts like stream and water. And it's placed far away from something unrelated like mountain. But it gets even more amazing. Its position tells us that the word bank in this context is much closer to riverbank than it is to a financial bank. See? The meaning isn't explicitly defined. It just emerges from its location on the map.
And this right here, this brings us to the core idea of this whole explainer. In modern AI, meaning is not some definition stored in a dictionary. Meaning is geometry. It's all about the distance, the direction, and the relationships between points in this enormous conceptual space.
Let's just compare these two ideas for a second. The old way, a dictionary, gives you a fixed definition for a word, all by itself. This new model is a map. It couldn't care less about definitions. It only cares about relational structure. It understands words based on their context, which creates this dynamic, fluid meaning that can shift and change.
And this famous example just shows you the sheer power of that map. This little equation shows that the model has actually learned the geometric relationship between concepts. The direction from king to queen is almost identical to the direction from man to woman. It has learned the concept of gender as a direction on its map. It's literally doing math with meaning. It's wild.
So what is this map actually made of? Well, it's encoded in the model's parameters, or weights. And we are talking about billions, sometimes over 1 trillion of them. But they aren't storing simple facts like a database. No, they are compressing the deep statistical patterns and the structural regularities that are found in all the data the AI was trained on.
So how in the world does the model learn to build this incredible map in the first place? Well, it all comes down to a task that is, believe it or not, surprisingly simple. But it's a task that, when you do it at a massive scale, forces a deep, structural understanding of the world to just emerge.
That task, it's just next token prediction. That's it. All it does is try to guess the next word in a sentence. But to get really good at that simple game, the model is forced to learn everything else. It has to learn grammar, context, and even the subtle patterns of cause and effect that govern our world. Prediction is the constant pressure that forges this incredible, understanding-like behavior.
And what's so cool is how universal this whole principle is. For language, yeah, it's predicting the next token. But for images, it might be predicting missing pixels. For biology, it's predicting how a protein is going to fold. It's the same fundamental math, the same process of learning relational geometry, just applied to different kinds of data.
The huge technological leap that really unlocked all this was the transformer architecture and its key innovation, something called attention. See, older systems had these fixed, limited connections, but attention, it allows every single token to dynamically look at and weigh its relationship to every other token, no matter how far apart they are. That's the secret sauce that unlocks true contextual meaning.
So, as we start to wrap this up, let's get really clear about what this amazing map actually represents. Does the AI model reality itself? The answer is a really crucial and kind of subtle no.
This is probably the most important takeaway. The AI is not conscious. It doesn't live in our world. It lives in a world made entirely of data. It has simply become an unparalleled master at finding the deep, hidden structural patterns in our observations of reality. And because our world has so much structure, that map ends up being an incredibly useful reflection of it.
So, if we put it all together, what do we have? The secret isn't in the pieces themselves. The tokens are just the doorway we step through to enter this new space.
And once we're inside, we find ourselves in a house that's built entirely out of geometry, where all meaning is defined by position and by structure.
The design principles of that house, the blueprints that show how everything fits together, those are the relationships between all the points inside it.
And the engine that powers this entire system, the thing that brought it all into existence and keeps it running, is that simple, relentless act of prediction.
So, in the end, what we're left with is not reality itself, but something that might be just as remarkable. A map. A map whose very geometry mirrors the deep structure of our own world.
And the most exciting part of all this? We are only just beginning to learn how to read this map. And maybe more importantly, how to use its lines to draw entirely new territory that we've never even seen before.